Right, hopefully you can all hear me, so thanks for joining today, folks. So my name is Paul, and I'll be talking to you today a little bit about streaming analytics with Apache Iceberg. So this is me. I've been doing big data for about 15 years or more now. So author, consultant, spent a lot of time in sort of customer space, helping people actually deliver tech for real. And I joined Redpanda back in 2023 because it was a really exciting place to be, really great to see that sort of innovation in that Kafka space. I'm here next today and tomorrow, so if you want to come and grab me at the booth, come say hi, come and chat about some of your data problems in that streaming space, very happy to do so. So what's the challenge, right? We're all into this crazy world that we're in, right? Now, this is Big Data London. Now, if you'd have been here 10 years ago, you'd have heard these three terms a lot, the velocity, variety, and volume. Those challenges haven't changed, right? We're all very familiar with the fact that we've got huge amounts of data, huge amounts of change going on, right? But what happened in the last 15 years or so is cost pressures have gone absolutely through the roof. We all are under extreme pressure to minimize our spend, to make sure that we can do things as efficiently as possible. And that's one of the reasons why Redpanda was born, right? We're here as effectively a more efficient way to do Kafka, both in terms of tech, but also in terms of your time and that operations capability, right? Much simpler to use, for example, that just means you can get on and do what you want to do. We're all familiar with this. We all work day to day with change. It seems to be the new constant, and this whole unrelenting complexity of the world that we live in, right? We're all in a position where lots of demands placed on us, so we want to make our lives as simple as possible, right? That's kind of what Redpanda is for, and we'll see how that extends, right? And it wouldn't be a talk if I didn't mention AI, so there you go. There's your token reference to AI, right? It is in here somewhere. So if you've been in this space for a while, you'll have noticed the fact that there's effectively a gulf, if you like, between the sort of streaming world and the analytic database world, right? On the left, you've got your sort of streaming platforms, and this has effectively been there as a way to sort of handle that real-time capability, but it's a completely different skill set, it's a completely different team, often different infrastructure, right? And then you have this analytic database world, which is often much more batch-oriented, very different kind of approach, different languages, right? You have things like SQL, for example, in the database world that you don't generally have much of in streaming. So whenever you have this kind of dichotomy between the two, you've always got to bridge it somehow. And the classic way to bridge this is with something like a connector-based architecture or some kind of ETL job. Think of a Spark job, right? Think of a Flink job. Think of a connector like Redpanda Connect or Kafka Connect. All of these options are a sort of an intermediary that sit in the middle, read from the streaming part of the world, and then write into that analytic database world, right? Very simple three-box architecture, right? And Redpanda has the same things, right? We have connectors within Redpanda. We have Redpanda Connect. And the Redpanda Connect is very, very simple to install and run. So once you've got the RPK command line, RPK Connect install, and you're away to the races, it just gets the whole thing set up. RPK Connect run foo.yaml. That's how we run a pipeline in Redpanda Connect. So it's about as simple as it gets. This is an example of a pipeline, and it's just YAML. Right? Now, the YAML here is an example going from Postgres to Snowflake, where it's a CDC pipeline. But as you can see, it's very, very understandable, very, very simple to get going on. And it's beautiful, right? Except for one big problem with it. And the problem is that let's say you've got a bunch of topics today. You've got one topic there, one connector flow into your analytic database. Right? Well, tomorrow someone says, actually, I'd like this other stream in there as well now. How do we deal with that? Well, you build another connector config, you deploy it, monitor it, water it, and then, you've got your new pipeline and everyone's happy. And now someone else comes and wants the third one, right? It's a big challenge. I mean, I have a customer that I was speaking to last week. They have on the order of 400 Spark jobs today getting their topics through to Iceberg into their bronze layer of their data so that they can then just do further analytics, right? This is a huge undertaking for large orgs. So, what do we do? The problem is clear is this, right? You've got this whole linear scaling property where as you increase the number of topics going forward, the amount of effort stays the same and you have to keep repeating that work, right? So there's got to be a better way, right? Now, clearly the better way is a connector that writes to Iceberg, right? That's not the way, folks. That's really not the way you want to do this by a long shot, right? The better way is to put the responsibility into the actual Redpanda product itself. So at this point, we've actually taken over the responsibility of all that connector and ETL flow, made it a core part of Redpanda, which is the Kafka replacement, the Kafka broker, written in C++. So you can now write direct to Iceberg and integrate against Iceberg REST, and you can do so by effectively just ticking a box, right? This is literally, virtually, what you have to do on a per topic basis to say, I'd like this stuff in Iceberg, please. There you go, right? That's a lot better than having to think about that connector config and have that sort of anti-pattern in the sort of scaling. So this is how we do it, right? Once your cluster is configured to actually know about your Iceberg, then effectively all you have to do is set the Red Panda Iceberg mode as key value on that one topic that you want, and all of a sudden the data is then going out into your Iceberg. I'll put a run your own demo slide here. This link is valid. It currently takes you to an empty Git repo. I've had demo hell this morning. My laptop physically ran out of space. Demo crashed. Things are everywhere, right? It'll be there by the end of Big Data London, but if you try and look at it now and follow along literally this second, it ain't going to work. Apologies. I've done my best. The demo gods have killed me with... And specifically, it's Polaris, actually. It's not the Red Panda part. It's the REST catalog. Anyway, I'll fix it. If you take a photo of the link and come back to it, we'll get you there, right? Right. So let's show you how to do this then. So we create an Iceberg table, as you've seen, by just giving that key value property, and then we just produce a message. Right? Echo hello world, straight through to our RPK command. And what do we do? Well, at that point, all the Iceberg work is done. To use it, you actually then need to connect the rest of your infrastructure, right? So you need to connect whatever part of the ecosystem you want to do. So for example, this is how you could do it in DuckDB, right? It's a very popular little database tool, very quick and efficient, very quick to get started. And here, it's just a simple script, say install the Iceberg capabilities, connect it to the Red Panda catalog that now exists in Polaris, give it a little bit of config, and once you have that little bit of config in place, then you can just go straight through. And with your DuckDB, use that as your init, if you like, for example, and then just issue your query. At this point, whatever you have in your infrastructure that can speak Iceberg and Iceberg REST is good to go against this data. Now, what we've done is we've enabled a very simple mode. It's called key value mode integration. Now, what happens in Red Panda is there's two different sort of styles of writing to Iceberg. The first mode I would describe as schemaless. And what we do is we literally take the raw bytes of your message and we write that out into effectively a value column in your Iceberg table, and it has a type of blob. Now, if any of you have done any SQL in the background, you'll all know that blobs are absolutely horrible to work with, but it at least gets you the data there to get started, right? But there is a better way. And this is how it looks if you say do a describe on that table. Well, you can see the demo table, do a describe on it, and you can see there are two columns. There's this one here, the Red Panda. That's a struct that contains useful metadata from Red Panda itself. So if you think about the Kafka topic, you're going to have things like the details about the partition that the message was from, the offset that was associated with it, the timestamp, for example. So all of this useful metadata is there ready for you to use. But the values just come through as a blob, right, which is a little bit less than useful in some ways. So we also have schema support. And this is the better way. This is by far the way you probably want to go for. And there are two versions of this, depending on how your data has that schema. Now, the standard Confluent way of doing this is to have effectively a magic byte and 4 bytes that describe the schema ID and then the actual payload of the message. So if you had an Avro message, it was encoded as Avro data, you'd have a byte for the magic, 4 bytes for your schema, and then all the rest of the bytes are your encoded data, right? We call that value schema ID prefix because there's a schema ID prefix in the value, right? Now, what happens is if you give Red Panda this context and say, Red Panda, this topic has data that is schema encoded, what Red Panda will do is it will then go and fetch that schema. It will figure out the layout of your data, be that in protocol buffers, Avro, JSON, for example. And when it writes it to Iceberg, it will actually stream it out using those columns and giving you that detail, right? So at that point, you then have full fidelity and proper SQL access to whatever's in your stream, right? So you have your topic, messages have schemas, they're all structured, and now we can get them straight into Iceberg. And this is all done by setting one property on the topic, right? Which is huge. We also support a version of the same process, but rather than having the schema magic encoded in the record, we effectively do a lookup to find out the latest schema associated with that topic. Imagine here that you've got this payload of Avro, Protobuf, JSON, whatever, it exists in a topic. So what we do is we go off to the schema registry, get that schema associated with that topic, and then encode it that way. And it's a little bit less flexible. You can only really use the latest value of a schema. Obviously, the version here, every message has a schema ID. So actually, you can have some producers producing slightly older data, some with newer, and as long as the compatibility is there between the schemas, and Iceberg instead of is supporting, you're away to the races. Right? So very flexible, and gives you full SQL-based access. So how do we do that in Red Panda? Well, it's about as simple as it gets. The only change, effectively, is, well, first of all, you need to actually register a schema, right? RPK registry schema create. Once you've registered the schema, now this is an example of a schema for JSON data, in this case, for telemetry. When you create your topic, all you have to say is value schema latest in this example, and again, you're all done, right? It's literally that one tick box that says, please do Iceberg, and just do that. And then there's an example of how to run this. I'd love to get this running. I've actually got Doom running on my laptop, encoding telemetry and sending it through. I'm sorry, I can't show you Doom. If any of you are as old as me, we all grew up on Doom, we all love Doom. There's a hacked version of Chocolate Doom, which has telemetry support for MQTT and Kafka. It's beautiful. You'll see it in the demo. Come back tomorrow when the demo works, right? Just bear with me. All right, so this is how it looks when it's running. So this is the old DOS-based display for the game, right? So you configure your display settings and, your VGA adapters or what have you. But there's a new one here for configure telemetry. And that's where you actually point it specifically at the Red Panda instance that we want to have. In this case, just pointing it as Red Panda, service cluster local inside my Kubernetes, and we're all good to go. And at that point, you run the game, right? Now, it's a bit of a glib demo, right? Obviously, it's here to sort of wow you and show you how cool this is. But there are real use cases from real gaming companies that use Red Panda today. I mean, one of the companies I was speaking to recently is using this to analyze the placement of objects in their multiplayer maps. So they use a historical analysis of all the games. So this is data in Iceberg. They do historical analysis. And they're using it to ensure balance within the game. So if you imagine a multiplayer game where it's two teams against each other, like a capture the flag type scenario, right? To not have a boring map, it's nice to have a map that is perfectly symmetrical, right? But the problem is, as soon as the map is not symmetrical on that game, the placement of items really starts to matter. Because actually, if you place some items a little bit sooner or a little bit easier to get to in one end, whatever team happens to be placed at that end of the game will have a much easier time than at the other end. So this kind of telemetry allows them to do historical analysis to look at game balance. You can do things like look at player behavior over time. Has someone suddenly started shooting a lot more accurately than they were a month ago, right? That kind of ability to sort of spot player behaviors, right? And you get the basics out of this, right? You get is my game running properly? Are the response times right? Are we matching players as we expect? So there's huge amounts of value in the sort of telemetry in this kind of world, but as in all worlds, right? Manufacturing, for example. I mean, a simple one for this is, even once I've got this demo going, I was using it to just investigate the contents of a topic. So today, if you want to look at a topic, you can use Red Panda Console, and you apply a few filters and see some messages. But actually, the ability to do SQL across the whole topic, and to do a massive group by with a count, and sort of see what types of messages you have, it's really simple stuff, but it's actually really valuable to someone who's actually dealing with the sort of day-to-day of dealing with life, right? So this is in this case, it's another example of that schema latest, right? And this is an example here of the schema that we're getting. So you can sort of see here we connect to DuckDB, give it our initialization to get in, and at that point we're just doing a describe just for demo purposes. And here you can see here's the Red Panda metadata again, the column, right, with the partition, the offset, timestamp, and whatnot. But then all of these columns, these are the ones produced by the game itself. So these are not, generated by us. We haven't had to say, map this column here, use this string here, this is a varchar, this is an int, or any of that. We've literally just said, this is an Iceberg topic. I'd like it in Iceberg, please. Make my life easier. Right? All right. This is giving you an idea then of what the initial setup costs. So I'll talk about this easily, per topic config that we just set and everything works. Kind of. There's a little bit more to it. There's always a little bit more, right? Real demos, look up my sleeve. But actually, this is it. This is the kind of config that we need to put in place to configure it to work. So we have to tell, now this is Red Panda. I'm installing Red Panda by Helm here. These are cluster configurations that go in. And what is it? Well, we've got Iceberg enabled true, catalog type REST. Where is the catalog? In this case, Polaris, my local Kubernetes. How do I authenticate against it? What credentials am I using to get in? All of these kind of things. But if you hit that QR code, it will take you to the docs page to show you how to configure all of the different kinds of catalogs to be supported. So Polaris is one, but there are many others, right? As we'll see in a moment. So actually, if you compare this amount of config to the config you'd have had to put in place to have a connector, actually this is probably less than you'd have just on a simple, straightforward connector, actually. So the costs are very low of doing this. And the point here is this, right? This is the winning slide, right? The beauty of that initial fixed cost being really low and then incrementally it just being ridiculously cheap to do is beautiful. Now, it's not for free, right? Any kind of time you're writing into Iceberg, you're writing Parquet data, which has to be encoded with all of the different columnar optimizations that implies. It's a slow process, right? But because we've moved it in Broker, Red Panda is actually written in C++. So it's going to be one of the most efficient and fast ways of getting data into Iceberg, because you're not running a JVM anymore for this, right? There's no garbage collection, there's none of that kind of tuning you have to do. It's all purely written in C++, which runs like the clappers, right? So very, very nice to do. We talked about Iceberg catalogs. Obviously, in this demo, I've been mainly going with Apache Polaris and mainly failing on the demo, but that's me. But yeah, Nessie is the other open source option. We also support file option for catalogs. But then there's the big commercial offerings as well, right? AWS Unity catalog has an open source version, for example. So all of these catalogs, if you click that particular QR code there, will take you to the support that Red Panda publishes. So yeah, definitely lots of support for different catalogs in there. And then you get access to all of the ecosystem. Right? This is the benefit and why you want to be doing Iceberg in the first place, is you have the ability to then use whatever tool your developers are actually familiar with. Right? If you have developers that are familiar with Apache Spark and want to do Spark, that's great. If you want to give someone just raw SQL access to ClickHouse or something like DuckDB, for example, you're straight on without any difficulty. Right? So it's a very simple way of getting access. We support some nice features as well. One of the ones that's beautiful is multi-level partitioning. Now, this is a nice one to think about, because if you think about what a Red Panda topic represents, you have a topic, you have partitions, and within those partitions, the messages arrive one after the other in a time-ordered fashion. And if you want to access and read and play all the history of a topic, you start at the start of that topic and you play all the way through. So you're always seeing that linear stream of the data that you wanted. But with Iceberg, you're not limited to that. So actually on the Iceberg side, you can configure partitioning such that when Red Panda reads your data out of your topic, not only is it writing it to Iceberg, but it's writing it into different partitions. So you could partition it by geo, you could partition it by sales channel, you could partition it by customer segment. Whatever feature is in your data can then be used. And this is multi-level partitioning, not single level. So you can partition by time and geo and segment. And the beauty of that is, effectively, it's like this sorting tray here. You're kind of sorting the data into these different bins as you go. So if you want to analyze the sales data for the US in the first quarter of the year, you can go and do that in Iceberg. It's just a simple select where those restrictions are in place on the where clause. And you're not having to read all of the data. You are literally just reading the data of interest. So it gives you an entirely different access pattern onto the same data that's in your stream. So Red Panda's still there, still has the data in the stream. If you want to consume in real time, Red Panda is absolutely the place you still want to do this. If you want to do historical analysis of what's in there in SQL, Iceberg is the way to go. Right? We also support dead letter queues. Now, there's a conversion process going on here, right? We're taking your formatted messages in Avro, Protobuf, JSON, or what have you, and we're converting. What happens if a message doesn't conform to the schema that you should have had? Well, in that place, rather than just throwing that messages away, what we actually do is we create a second table with a tilde DLQ. We call it a dead letter Q, but it's a table. I've had arguments with that with our product files. To me, it's a dead letter table, right, rather than a dead letter Q. But people know the term dead letter Q, therefore that kind of makes sense, right? So what we do is we can then, all the data that's valid gets written into your main table, and anything that doesn't conform goes into your dead letter queue. And you can then look at that over time, look, how big is the dead letter queue? Do we need to do anything with it? Do we need to reprocess this stuff? Do we need to change an upstream process that's publishing to Red Panda to make sure that the data comes through in the right scheme, right? So very, very, very simple, but very flexible. And that comes by default. You don't have to enable it, right? As soon as you have a schema that doesn't match your data, we will create that table and we will just throw the data in there for you to look at, right? So really simple stuff. I've been given the 10-minute warning by the nice lady at the back. It's actually 9 minutes left now. The link is still there for the demo, the missing demo. It will be there. But I'm here for today and tomorrow. You never know. I may get it working by then, so come and bother me and rib me about it at the booth. If I haven't got it done by tomorrow, come and give me a punch. But yeah, come over, say hi, grab a free T-shirt with every conversation. It'd be great to meet you all and sort of chat about what it is that you want to do with your streaming data. At this point, I'm happy to open it up for Q&A. We have a question. Hang on, let's get the mic, and we'll do it that way, because I can't quite hear you.
Hi, can you hear me now? I see you doing like a single message into your topic and then writing to Iceberg, right? How do you handle like batch? Do you handle batch messages?
Yeah.
Like how does that work?
There's a couple of things going on. So whenever you consume from Red Panda, if you want performance and high throughput, it's always good to tune your consumer to consume at a high throughput with big batches, right? But also on the Iceberg side, there's a trade-off between how quickly you want to get the data out, how much data accumulates, and therefore the ending file size. So what we do is we have parameters you can tune that say, how quickly are you willing to wait? I think by default it's something like 60 seconds. So whatever messages you've got in those 60 seconds, then we'll take that chunk and we'll write that out to Iceberg. And what that does is it gives you a nice balance between how quickly is the data arriving in Iceberg versus how big the resulting files are. Because from a performance perspective with Iceberg, you want to have as big as files as possible because that means that your downstream processes that are reading the data. Imagine you've got a gigabyte's worth of data, right? If you wrote it in 1 kilobyte chunks, you'd have 1 million files and you'd have a big time in whatever tool to try and read it. But if you wrote it in 1 meg chunks, you'd only have 1,000 of them, right? And that's much more doable. Fewer requests to S3 and so forth. So yeah, it's absolutely tunable.
That was the delay, your lag setting, right? It's in your YAML.
Yeah, there's a lag. There may even be a size one. I'm not sure. I'd need to look.
Cool. Thank you.
Come grab me at the booth. We'll have a look at the docs.
That's awesome.
Oh, folks are going to let me off lightly. That's good. Does anyone want to see a live demo and watch it fail? No, don't say yes. All right, let's do the live demo just in case. I put it at the end just because I knew this was always likely to go crazily wrong. Let's have a look-see. There. All right. This at the top is, if you recognize it as K9S, this is effectively a view onto Kubernetes. What the demo does is it builds a local stack of MinIO. Then it has, which is an S3 compatible storage, right? Then we use Postgres, which is then used as a persistent database for Polaris. We then install Polaris, and finally we install Red Panda. And I'll show you actually the setup. So when it's published finally, this is the script of all scripts that does the work. All right, so the first thing it does is it installs MinIO, configures it, then creates some local buckets. Then we install Postgres, then we install Polaris, which is where the troubles are. Then we install Red Panda Catalog and the associated RBAC. And then we put some RBAC rules into Polaris. Finally, we install Red Panda and go. Now, I did record a demo of this, just in case. And if I do play of setup, shh. So this is a recording I did literally And here we can see, is this gonna, I'll zoom in a bit. All right, so here I'm doing the Helm install of MinIO. This is actually doing the Helm install. It's from Bitnami for the moment at least. That worked, great. Now what do? We configure and get out the passwords and stuff, because we need to obviously configure Polaris and Red Panda, because they're both writing to MinIO, right? And once that's in place, we can then create some buckets. Excellent. Here's the Postgres stuff. Here's the Postgres. Nothing too clever. Right. This is me installing Postgres and then configuring Postgres for Polaris, right? Which is effectively, if you think about Polaris, it has its own need to store data persistently somewhere. We chose Postgres for this. You obviously need to create the database for Postgres or the users for Postgres and things like that, right? Then we're on to actually installing Polaris, and once you've done that, I created a Bootstrap job, which is very nice, which creates the realm. So I could show you that. I'll leave that on. It's not that interesting. Once we've done the creation of the realm within Polaris, there's a port forward because we need to interact with it, and there's a bunch of curls that we do after creating the catalog. So this is the Polaris command that's been throwing me for a loop this morning because it's destroyed my Python. Doesn't matter. But anyway, that's how we create in Polaris. Other catalogs are available, and other catalogs might not have these problems. Keep that in mind. So once you've created the realm, we then get a token out to access, and that's a little bit of validation just to make sure it works. There's a little bit of SQL, a little bit of curl to create the RBAC stuff. Yeah, it's all very good. Here's Red Panda. Boom, boom, boom. All right, everyone's happy. All right, what does it look like when we actually use it? All right, so this is the actual usage. So under the demos folder, demo 1, this is going to be just a key value example, right? So nothing crazy. So the first thing we do is create a topic, and you can just about see it at the bottom there, RPK topic create demo. Then once we've created the topic, we're going to write a message, as you'd expect, echo hello world. It looks a little bit more complex than the one on the slide, because Kubernetes, right? Kubernetes always has a little bit of a tax on it, right? But once the message is in, we can then do this duckdb count.sql. And how was that defined? Well, let's have a look in the actual demo. Count.sql. Counts are from Iceberg Catalog Red Panda demo 1, right? It's very, very straightforward for your SQL analyst to then start using this stuff, right? So, I think probably with that, I'll leave it there and thank you for your time.